Yeah.
Okay. So these are the basic materials which are available in the market. Then we have starting with the subgrade soil. So can you tell me what is the difference between subgrade soil, subgrade and the embankment? What is the difference between subgrade and embankment? Anybody has?
Embankment, sir.
So CBR
CBR.
are different.
But this is not the basic difference. Correct? You CBR are different for subgrade and the embankment. The requirement is different, but it is not the basic difference which part is called as subgrade and which part is called as embankment.
Sir, subgrade can be defined as the lower surface of the carriageway, and the embankment is the full area like roadway, including shoulders.
Not very correct. Who is speaking?
Pooja Rani.
Pooja is speaking. Pooja, those who are speaking, they can tell their name also. I will be happy to know that who are taking interest. So, Pooja, what you are saying is that if this is the pavement, so, and this is the shoulder, you are saying in this part it will be subgrade, while this in this part this will be embankment. Full part will be embankment. You are trying to say this.
Yes, sir. Yes.
No, it is not correct actually. Now,
Sir.
Yes.
Sir. Subgrade soil is, sir, a carriage with 1 kilometer. The CBR value is above the 6 and 5. Or apartment soil is, sir, near the apartment soil. This is less CBR value.
Your answer is not to my question, though your answer is correct. Your answer in the way is correct that CBR of subgrade is more than the embankment.
Apartment, sir.
But my question is how you decide that this is embankment, this is subgrade. Who is speaking?
Vidya Bhushan Kumar, RWD.
Odisha.
Bihar, Khagadia.
I can understand from the language that from which state you are, but I try to because I have told you that I have worked in different states. So God has given me this gift that just when you speak, I can tell you from which state you are.
Sir.
But I want that all of you should take the interest. That is why I'm asking the names also when you are speaking. So good. Your answer, as I said, is correct, but not exactly to my question.
Sir.
Any other answer?
Sir, subgrade is I guess a position of just below the surface level. It's called subgrade, and embankment is which is built above the original ground, sir. Like by by depositing, by cutting, filling through, sir.
You can see this. Who is speaking?
Sir, subgrade is free from roots, grass, and other materials.
No, it is not.
But
Like
embankment is
now you see the top layer is the wearing course, then we have the base course, then the subcase course, and then the subgrade. Subgrade and embankment are the same except that top 30 to 50 centimeter of the embankment is known as subgrade. For the rural roads, it is 30 centimeter. For main roads, it is 50 centimeter of the embankment is treated as the subgrade. It is more compacted. It is having better soil. It is having more CBR. All of your answers were correct that way. But to separate out subgrade embankment, you have to tell that the top 30 to 50 centimeter of the embankment is known as the subgrade. And as I said, this is in the whole width, whether it is below the carriageway or whether it is below the shoulder, because these are the shoulders. Rather, these are the shoulders. So these are the shoulders, but subgrade continues up to the shoulder also, right? The supporting soil beneath pavement under course is called subgrade 30 to 50 centimeter. These are the desirable properties of the subgrade, that is stability, incompressibility, permanency of strength, because the load which is coming on the bearing course is transferred to the base course. Base course transfers the load to the sub-base course, and the sub-base course transfers the load to the subgrade, and finally the subgrade transfers the whole load to the embankment. So these are the requirements for the subgrade. The soil can be divided into 4 parts, that is the gravel, the sand, silt and clay. Normally for the roads, clay is not desirable. Clay materials are difficult to handle. They have more PI, they have more problem of soiling. So in the roads, we normally avoid the clays. Best are the gravels, then sand and then silt. Broadly, the soil types can be categorized as laterite soil, muram, red soil, desert sand, alluvial soil, clay, including black cotton soil. So these are the definitions of gravel, muram, silt, and clays. As I said, that these are the most biggest size is of the gravel, while clays are the clays. You can say that for the purpose of farming, clays are good because they can retain the water. But for our purpose, we don't want a soil which is retaining the water. We want a good drainage. And that way, clays are not having the good drainage. And you can say that clays should be avoided, even in the sub-base course or base course where you are using WBM. When you are using WBM, that is water-bound macadam, you have the binding material as the soil. And this soil should have 4 to 6 PI. While the clays are having the PI more than 15, which are not desirable. And what you can do in that case if you are having the clay in your area, because roads are not of that commodity that you can shift the material. You can you have to use the same soil which is available in that case. So in what you have to do is, in case of soil, you have to do the soil stabilization. And what is the soil stabilization? Soil stabilization is of, you can say, one is lime stabilization, another is cement stabilization, third is fly ash lime stabilization, and fourth is bitumen stabilization. For the clay soils, normally we go for lime, cement, or the combination, that is fly lime stabilization. For the desert sands like in Rajasthan, we go for bitumen stabilization, so that the strength is increased. And to know whether the soil is useful to us or not, there are different type of tests on soils that you can see now. The main function of the subgrade is to give adequate support to the pavement, and for this, subgrade should possess sufficient stability under adverse condition. The tests used for this are shear test, bearing test, penetration test. So, but main test which we are doing in our country is the Cbr test. Though these all tests are available for the embankments, but for the pavement design, we still go for the Cbr test in the country. Cbr test, you understand what is that? It is known as the California bearing ratio. And California bearing ratio is the ratio of the load to give 2.5 mm penetration for your material divided by the load required to make 2.5 mm penetration for the standard material, which is given as 1370 kg for 2.5 mm, and for 5.0 mm it is 2055 kg. right? And in this case, what we see normally the Cbr is more at 2.5 mm, and we report that value. You know that if you have this curve like this, so corresponding to 2.5 mm, suppose this is 2.5 mm, this is 5.0 mm, corresponding to this load, you have to find out the values. That value say it is A, this is B. So 2.5 is A divided by 1370, 5.50 is B divided 2.2055, and whichever value is more, you have to report that. Normally it will be more at 2.5 mm. If it is not, then you have to repeat the test. Even if it is coming more at 5.0, then you have to report that value which is coming at 2.5, 5.0 mm, right? And one test is to be done before this also, because you have to use the water in Cbr testing. So how you decide the water in the Cbr test? What amount of water is to be used in Cbr test? Can anybody tell? Can anybody tell how to decide the water to be used in the Cbr test? It is to be decided by Proctor test. In the Proctor test, what we do is we add some water, compact it, and then find out the dry density. Then we increase the water, find out first the wet density, then the dry density. Add some more water, find out the wet density and the dry density, and then we draw a curve which is in this form. Initially, when you are increasing the water, the density or the gamma D dry density is increasing, but at a certain point when it is maximum, it is known as maximum dry density, and it is corresponding to the value of OMC, optimum moisture content, right? So can you tell me now that why we want to make the highest density or the maximum dry density in the field? This optimum moisture content is used in Cbr test so that the maximum density is maintained. Why we want to use the maximum density in the field?
Sir, for worst condition, sir.
For
Worst condition.
worst condition. That is the moisture content you are saying, that we make the sample at optimum moisture content, but to make the worst condition which will come in the field, what we do is we put the Cbr mold in the water tank for 4 days. I'm not going in detail of this test because the testing part will be taken over by some other person. I am trying to just give you some idea or the basic or the practical aspect of this. We put the sample in the water tank for 4 days to make it the worst moisture content or the worst field condition. But my question was something else. I was asking why we maintain the maximum dry density in the field, and which is to be maintained in the field also, which is used in the lab. The same we use in the field, maybe 98%, 99% of the lab density we maintain in the field also. So why this concept has come that in the field we should maintain this maximum density? I tell you that suppose this is the road. Then if I put something here, it will be compressed. Again, I increase the load. It will be further compressed. Again, I increase the load. It will be further compressed. But then a condition will come. Then you will say, now it has reached its ultimate condition. You apply any load, it will not be compressed now, because it has reached the ultimate condition. So we want that whatever maximum density is possible, that we have found in the lab by increasing and the moisture content or decreasing the moisture content. And then we told the field person that, okay, you maintain this density in the field of the soil, right? Depending upon the importance of the road, we decide 97% of the lab or 99% of the lab is to be maintained in the field, so that due to the movement of the traffic, there is no further compression in the pavement, right? Now, these are the tests which we have seen. Now, in the laboratory, we do the evaluation, we do the field evaluation, and then we use the analytical and mechanical concepts. For that, the different loads are to be taken, like stationary, moving, heavy, light. Climatic conditions are to be changed, that is temperature, rainfall, moisture. We have to check the material behavior. For that, you have to see the stress-strain relationship. I will again tell you that for the field persons, the main test is the Cbr test, because our design is based on the Cbr test. But for the in-depth knowledge, to the in-depth studying of the behavior of the materials in the lab, we have to go for stress-strain relationship also. We have to see the time temperature dependency, effect of moisture. We have to see the magnitude, time and frequency, nature of the load, and the temperatures to which the material is to be used. Let us start with the aggregates. So now from the soil, as I have already checked, we have now come to the aggregates. So we have to see the origin and production of aggregates, their mineralogy, and there are three types of rocks from which the stone are coming. Can you tell me what are three types of rocks?
Sir, igneous, metamorphic,
And
Sedimentary.
and sedimentary, right? Igneous rocks are coming from the solidification of the magma. Sedimentary rocks are due to the layering or the silting by the rivers, and metamorphic rocks are due to the weathering of either the igneous or the sedimentary rocks, right? So depending upon their source, their quality is also different. Igneous rocks are more strong than the sedimentary rocks. Right? These are formed by the deposition of insoluble residue. These are calcareous containing calcium carbonate, glaciers. Then metamorphic rocks may be igneous, as I said, or sedimentary. Then we may have the gravels, which requires crushing. These are the bigger, more boulders. Then we have the natural sand, which is coming along with the rivers. Then we have the slags. Slags, I have told you, are coming from the steel plants or other copper plants or different other type of plants. So the test which we have now for this are, I will tell that these tests will be covered in detail by some other faculty member who will be telling you about the test. But in short, I want to tell you that what is impact test. In the impact test, we measure which property of the aggregate? Who can tell? Which property of the aggregate is tested in the impact test?
Toughness.
Yes, it is correct.
Fine aggregate.
It is toughness. Yes, it is the toughness, because by putting 15 blows of this hammer will touch here 15 times. Because of that, you have it is broken, and then we sieve it through 2.36 mm sieve, and that way it gives you the value of impact value. Second is the abrasion test. Which property we measure in abrasion test? Who can tell?
So the frictional
Hardness.
property.
It is somebody else.
Resistance.
Resistance to wearing and tearing.
Wearing and tearing, but correct answer somebody has given.
Hardness.
Yes, it is the hardness.
Hardness.
Yes, it is the hardness.
Hardness.
Okay, it is the hardness, while in this case it was the toughness. Right? So in this case of Los Angeles abrasion test, it is just like you have seen in circus. A motorcyclist is moving in a sphere. Have you seen circus? In circus, there is a sphere in which a motorcyclist moves like this. He goes up to
मौत
the
का
top, right?
सर मौत का कुआं
Yes, Maut ka Kuan. Very correct answer. In Maut ka Kuan, what you do, you see that this motorcycle person is going up, and at the top also he is going, but he doesn't fall down. Why he doesn't fall down? Which is the force which is stopping him?
सेंट्रीफ्यूगल सर
It is centrifugal force which is acting in this. It is given by mv square upon r. Similarly, in this, the aggregates and the balls are there which are moving up and going up but not coming down because of the centrifugal force. That is why the speed is to be maintained as 22 to 33 revolutions per minute. So that it is moving but not coming down. It is going and coming down, but it is not sticking to the sphere. And if it is less than 20, then it will not go up. It will remain on the bottom side. So that is why you have to maintain this. Then we have to do the durability and soundness. Soundness is a test against weathering. Then we have to do the size and shape test. In this you have the test of flakiness. You have the test of elongation. Flakiness is a test basically of if I take an example, suppose this is a material. It is flat. So it can be broken easily from here. But if this is the shape, then it will be requiring more pressure to break. If it is like this, it will be requiring more pressure. If it is like this, it will be requiring more pressure. It is like this. Finally, in this shape, it is not flat. So those particles which are having their least dimension less than 0.6 times of the main dimension are known as the flaky particles, and that are to be avoided. Similarly, if you see that this is the elongated particle in which the longest side is more than 1.8 times the main dimension, then it is the elongated particle. If I make it simple, for example, if this is the particle, this is not elongated. So this will be not easy to break. While in this case, it is the elongated particle. So that is to be avoided. Right? So that way, other tests are angularity number, but of course nowadays in IRC code you will not find the angularity number. It is not there. Now we come to the bitumen. Bitumen, as I have said, is used in most of the roads. We are having more than 90% roads or more than 95% roads are the bituminous roads or the flexible pavements in the country. Why we use bitumen? Why not we use kerosene? Why don't we use any other material in road construction? Why we use only the bitumen? Can you tell me what is the reason? What is the reason we use bitumen as the binding material in flexible pavements? Any answer? Please
Sir,
unmute.
bitumen has the property of as a adhesive properties. So it can bind the aggregate and other materials.
In a lighter vein, if I say, can't we use Fevicol there? It is also has the adhesive property.
Sir, actually, bitumen is a byproduct of petroleum or coal.
Again, in petrol is also a byproduct. Kerosene is also a byproduct. Can't we use petrol or kerosene in road construction?
Sir, bitumen offer
which is
good
also
grip,
binding.
sir.
Yes, one by one.
Bitumen offer good grip as compared to
So it is
coal,
impermeable
sir.
in nature.
Sir.
Yes, it is in nature.
Impermeable in nature.
Other materials are also there.
Sir,
Sir,
actually it is cheap.
सर
Say
बिटुमिन
comparatively
वेस्ट
cheaper.
प्रोडक्ट है सर पेट्रोलियम का, तो इसको यूटिलाइज कर लेते हैं सर, इसके अलावा इसका और यूज, और सर चीपर
If
पड़ता है
it
उनको
is a
बाकी
waste,
सबसे।
it is a waste material. There are other waste materials also in the country. Why don't we?
Say
सर इट
Sir,
हैज
bitumen offer good grip, sir.
Uh, any other answer you feel which is different from the answers given by you? Any other answer? Answer is written on the screen.
Waterproof, sir.
Not that answer.
consistency.
It is because of its consistency at different consistency at different temperatures. You want a material for construction which should be liquid. It should be liquid when you are using it or when you are mixing it. It should be liquid at the time of mixing. It should be semi-solid at the time of compaction. And it should be solid at the time when you are using it. And this bitumen has all the three properties at different temperatures. When you are heating it, when you are mixing it at around 160 degrees centigrade, it is a liquid. You can mix it very easily. When you are compacting it at around 120 to 140 degrees centigrade, it is a semi-solid. It can be compacted. And when you are using the road, it behaves like aggregate only. There is no difference between aggregate and the bitumen because at the temperature below 50 degrees centigrade, it is a solid or the aggregate. Because of that, you are using bitumen. Otherwise, you may have different liquids available which can be mixed, but they will not become semi-solid or solid at low temperatures. You have solids which can be mixed, but they cannot be mixed at that temperature. So because of this good quality, this is a special quality of bitumen that it behaves differently at different temperatures. It is used in the road construction. Right? So this is the background of this. These are some properties of bitumen. The tests for the consistency are penetration, softening point, ductility, viscosity. Then you can see here, in the case of physical test, you have the penetration test. You know in the penetration, we apply a needle with 100 grams load for 5 seconds and standard temperature is 25 degrees centigrade, and we try to find out what is the penetration of the needle. Then we have this softening point test in which we see the temperature at which the balls touch the lower plate. Then we have ductility test in which we put the bitumen in a mold and try to find out at what distance it is going without breaking. Then I tell you what is basically bitumen. It is the mix of two materials, maltings and asphaltines, right? And in this, maltine is non-polar and asphaltine is insoluble polar. The combination of them make it bitumen. But till now we were discussing about the qualities of bitumen, but it has some drawbacks also. What are those? First drawback is oxidation. Though oxidation for the human being is also there, we start aging. After a certain age, we feel that our body is decaying. That is true for the human being, that is true for the living thing, that is true for the non-living things also up to certain extent, and especially the bitumen. Due to the oxidation, it becomes hard. That is also known as hardening of the bitumen. And that is hardening or the aging of the bitumen. Second drawback is the water effect. Sometimes when the water logging is there, then what happens? The separation starts between the aggregate and the bitumen, and the water enters between the aggregate and the bitumen, resulting in graveling, resulting in potholes and other properties. Right? So water is the enemy of the pavement. If you know, our teachers used to say there are 3 enemies of the pavement. Which are those? First enemy is water, second enemy is water, and third enemy is also water. If you can save your pavement from water, then it can work, it will live for thousands of years. But it cannot be done. Just like when you go to buy an umbrella in the market, and if the shopkeeper says that it is a very good umbrella, but keep it away from water. How is it possible? When you are taking the umbrella, you are purchasing the umbrella to safeguard yourself from the water or the rainwater. And if he says that you keep it away from water, it is not possible. Similarly, in case of road, water cannot be separated out during the rainy season. Water is bound to come to the pavement. Pavement is not such a commodity which can be put in a refrigerator, in a heater, in a almirah. It is to be put in the oven. It is to be put in the open. That is why water effect is there, and we have to take care of that. Third is the temperature effect. I explained that because of the behavior of the bitumen at different temperatures, different behavior, it is in use. But excessive thing of any material, any person is not good. Similarly, in case of bitumen, if the temperature susceptibility is too high, temperature susceptibility. Temperature susceptibility of the bitumen is very high, then it will create the problem. For example, in the month of June, where the temperature is very high, then what happens? Can you tell me what happens in the month of June with the pavement?
Bleeding occurs.
Yes, it starts bleeding. Correct answer. Bleeding is there, and because of that bleeding, the pavement bitumen comes over the pavement, and it doesn't go back. It doesn't go back to the pavement even after the temperature has gone down. Right? So that is known as excessive temperature susceptibility, which is not desired. If you feel that the bitumen is good because of the temperature susceptibility, it is bad also because of excessive temperature susceptibility. Similarly, at the low temperatures, it starts the cracking because bitumen becomes too hard. So the quality which has made it suitable for the road construction, the same quality, if is in excess, will make it unsuitable for the road construction. And the last one is the high cost. If the cost is very high, right now, what is the cost of bitumen? Can you tell me? What is the cost of bitumen? Who can tell? You all are feeling.
46,000 per ton.
Pardon? Sorry?
46,000 per ton.
46,000 per ton, or in simple way, 46 rupees per kg.
Yes.
Almost. Varying at different places, maybe 40 rupees, varying from 40 to 45 or 46. If you are going for modified bitumen, then it may be little high. But if I know correctly, it is around 40 rupees per kg for the normal 80-100 or 30, or 60-70 bitumen. Now, aging I am discussing is again of two types, short-term aging and long-term aging. Short-term aging is during construction. And long-term aging is during whole life. During construction means bitumen was heated, mixed, transported to the site, compacted, and cooled. This whole process is during construction. The time when it was heated for the mixing, mixed, transported, compacted, and cooled. All this process is known as the process during construction, and in this process, the aging is taking place that is known as the short-term aging. While for the long-term aging, during the whole life, this oxidation or hardening takes place, that is known as the long-term aging. For the short-term aging, you can see there, this is the machine rolling thin film oven. Rolling thin film oven is the test which is conducted. We put the bitumen in this and then we try to find out what is the hardening, what is the changes in the bitumen. This is for the long-term aging. This is for the long-term aging. This is known as PAV, pressure aging vessel. This is wrongly written here. It is not rolling thin film. It is PAV, that is the pressure aging vessel. Now, method of grading of bitumen. How we decide the grading? Earlier we were doing the penetration grade. Penetration grade was decided just like if it is say 80 by 100. What is the meaning of 80 by 100? Anybody can tell? What is the meaning of 80 by 100 bitumen? Who can tell? When I am saying it is 80-100 bitumen or 60-70 bitumen, what is the meaning of this?
Penetration depth.
Penetration depth is what? In the penetration test, we try to find out what is the penetration of the needle in terms of 1/10 of mm. Suppose the penetration was 9 mm. Then in terms of 1/10 of mm, it will be 90 of 1/10 mm. And this is in between 80 and 100, then this will be known as 80 by 100. If this is between 60 and 70, then it will be known as 60-70 bitumen. Right? And this was a normal procedure. I hope still you are maintaining in the country, we are maintaining it. People, old persons, those who are working in the field, they use this term 80, 100, 60, 70. This is based on the penetration. That is why the name is given as penetration grade. Right? Second is, which has come nowadays in use in the country, is the viscosity grade. We have VG10 and VG30. This 60-70 is known as VG30 now, and 80-100 is now known as VG10. Because it is based on the viscosity of the bitumen. Instead of the penetration of the bitumen, now they say it is better to grade them based on their viscosity, and that is why, as a thumb rule, 80-100 is VG10, 6070 is VG30. Now VG40 has also come into the market. But in general, you decide based, just like in this case, you were deciding the grade based on the penetration of the needle. In this case, you are deciding based on the viscosity of the needle. Right? Now the third thing which is coming in the market, which is not still used in India, but worldwide people are discarding this penetration grade, they are discarding viscosity grade, they are going for performance grade. This is SHRP specification, sharp specification, which says that the bitumen should be decided by performance grade, which is given by PGXXYY. XX is the temperature, the highest temperature up to which this bitumen can work, and YY is the lowest temperature up to which this can work. So just seeing the bitumen grade, you can decide that in your area, which may be the high altitude area of Uttarakhand, where the temperature is very low. It may be the high temperature of Tamil Nadu or Kerala, where the temperature is high. You can decide that which grade is to be used. So this performance grade is to be used for that purpose. And the researchers have switched over to this now. In India also, if you find the research papers, they are using PG grade. This is totally discarded. Penetration grade has been totally discarded. VG grade, VG viscosity grade is still in use, but we are slowly, gradually switching over to the performance grade. And for that purpose, we are doing the rheological test, that is using the DSR, dynamic shear rheometer, and throughout the world, this is the new research which is going on, the rheology. Right? All the materials, especially the bitumen, is put on the anvil for suitability of this material, and for that purpose, we do how it is behaving in rutting, how it is behaving in fatigue. Rutting means high temperature. At the high temperature, it go for rutting. Rutting is basically the depression in the pavement along the road or in the longitudinal direction at the mean wheel path of the vehicle. If this is the road, so normally we have the tendency to move at a certain distance from the edge. We maintain a certain distance from the edge, which is 0.6 meter in case of rural road, that is a single road. So along this wheel path, there becomes a rut. That is a depression. Similarly, in this direction, there is a rut. So this is known as rutting. While fatigue means there are cracks, which may be of different type, maybe longitudinal cracks, which may be the crocodile cracking. So there are different type of crackings also. So what are different distresses or the failure types that also you can see when somebody else will take this course also on the failure of the pavement. Right? So this is regarding the main test on anvil, where you will put the material and you will try to find out whether it is behaving properly or not. Now all those tests like penetration, softening point, etc., they are not in much use. Now in use is the V star, that is the complex modulus. Why we are using this? Earlier, as I have said, we were doing the penetration test, we were doing the viscosity test, etc. The purpose was to indirectly find out the viscosity. Viscosity decides whether it will be able to use it or not, but it was not the viscosity itself. It was a indirect measure to find out the viscosity. Because in case of penetration test, what you find 1/10 of mm of the needle insertion. That is in terms of 1/10 of mm, but it is not viscosity. Viscosity is found in the terms of poise or in centimeter strokes, which is not there. Similarly, in case of softening point, what we measure? We measure the temperature in degree centigrade at which the balls touch the lower plate. So that is temperature, not the viscosity. Similarly, in case of ductility test, what we do? We find out the distance up to which the thread can be maintained. That is in centimeter. That is not the viscosity. So now in the new system, we have dynamic shear rheometer in which we find out G star complex modulus. We measure the phase angle. Phase angle is basically the gap between stress and strain. The phase gap between stress and strain when we applied a sinusoidal load on the bitumen sample in DSR, the strain lags it by a certain angle which is known as the phase angle. This is the rheometer which we use. Of course, this is the old version. Now the new model has come at IIT Roorkee also. In BHU also you have a new version. But this was the second type of rheometer which we have used and which is available at different colleges. Then this is the template for taking the values. Now next is the polymer modification. You are using now PMB also. Of course, in rural roads, we have not given permission to use more, but still at some places you are using the PMB also, polymer modified bitumen. This polymer modified bitumen is available in the market, PMB 40 or other materials. So why we use these materials? So the answer lies in my earlier explanation when I was telling you about the problems of bitumen. And the major problem of the bitumen was excessive temperature susceptibility. So to reduce the excessive susceptibility, excessive temperature susceptibility, we use the polymers. They increase the strength, but main function is to reduce the temperature susceptibility, to reduce rutting, to reduce fatigue cracking. Right? So this is about the why we use, and in the market you have mainly three type of. This is elastomer, this is plastomer, SBS is styrene butadiene styrene, EVA is ethyl vinyl acetate, and CR is crumb rubber. These three materials are nowadays available in the market, and at the academic level you will find that at least 500 theses have been done in the country on use of these materials during the last 15 years. And in every thesis, the result was that SBS is good for the high temperatures, that is for the rutting, while EVA is good for the low temperatures. So these are the advantages of modified bitumen, that is better addition between aggregate and binder. Dr. Ankit, when I have to stop, please tell me.
Sure, sir. Sure, sir. You can take me 5 minutes more, sir.
Okay, okay. So you can stop me whenever you feel that the time is over. So advantages of modified bitumen are that there is better adhesion between aggregate and the binder, lower susceptibility to temperature variations, higher fatigue life of mixes, better age resistance of properties, and higher resistance to deformation. These are some tests from the DSR, like G star upon sine delta is the test which is found to check whether it is good for the resistance against rutting or not, while G star is for resistance against fatigue. This is for Rutting. So G star upon sine delta, as I have explained, G star is the complex modulus and delta is the phase angle. And these are the tests, main tests, and this also decides, G star upon sine delta decides whether what is the filling temperature. That temperature at which G star upon sine delta is, it should be more than 1 to work as a good resistance material, but when the value is going down from 1, then that sample is assumed to be filled, right? And because of that, we say that we can find out the PG temperature or PG grading can be done by this method also, by G star upon sine delta. Similarly, the G star upon sine delta should be less than 5000 if you want that it is behaving good for the fatigue resistance. This is again showing you a 10 radian per second for 80 by 100 bitumen modified with crumb rubber. These slides are basically done by some students, my PhD students who have worked there in different areas. There are 5 students who have worked in the area of modified binder. So some of the slides I have taken. Some of the students have worked on the pavement evaluation, like Dr. Ankit Gupta worked on pavement evaluation. He worked for the Bankelman beam, etc. He may be taking your lecture on that area, but that is the evaluation of the pavement in field. But what right now we are discussing the evaluation of the materials only. The second part becomes the evaluation of the material of the road in field. So now effect of stone. We again come to different type of stones. This work was done by Dr. Maninder, who was my PhD student long back. So he worked, there may be different type of stones. Like granite is there, it is the igneous rock, and these are the metamorphic rocks, that is marble and quartzite. He tried to find out these 3 materials, how they are behaving. And he used 3 bituminous type of materials, that is VG30. I have explained VG30 means 60-70. He used SBS. This is the SBS picture, that is styrene, butadiene, styrene. This is EVA, that is ethyl vinyl acetate. So it is showing you in the marble, it is the 0% silica and 100% calcium carbonate, that is, it is the calcareous type of material. The quartzite is having 100% silica, so that is it is acidic, and it is having 0% calcium carbonate. And while the basalt, dolomite, etc., these are the in-between materials. This is showing the failure of the materials. This is showing the wheel rut tester, where you have taken a sample and this wheel is moving over this tester, over this slab, and we try to find out in the lab how it is making the rutting in the pavement. Similarly, in this case, you have, this is the friction of this. There is a small slab put here. There is a pendulum. It is put over there, and depending upon the friction, surface resistance of the friction, we try to find out here. So I think lastly, instead of moving further, I should take some questions if you have, because my presentation may take around one hour or half an hour more. So better I stop here, and then if I take some questions from your side.
Yes, so I encourage participants, like this is a great opportunity to interact with sir. If you have any questions, any doubts, or any general questions related with the PMGSY also, please feel free to ask.
Sir, nowadays cold mix technology is widely used. So that cold mix between that cold bitumen, does it change its property with temperature?
Actually, when I was telling you the temperature susceptibility of the bitumen, it was behaving differently at different temperatures. So people found another way for changing the consistency. So in case of cold mix technology, there are two things. One is the cutback, other is the emulsion. In case of emulsion, what we do is we add water with bitumen so that instead of going to 160 degrees temperature, at the normal temperature, it behaves like a liquid. It is having 66% bitumen, 33% bitumen, and 1% the emulsifier, that is the soap. The soap makes the two materials, that is the bitumen and the water, miscible. Of course, this is a globe. One is available in the form of globules. In the other, they are immiscible, but they are mixed. And so that in the beginning, when the mixing is to be done, it is a liquid. After some time, water evaporates and it becomes semi-solid. And after again compaction, it becomes the solid condition. Similarly, in case of cutback, it is added with kerosene or petrol, and those materials also evaporates after the compaction. So whatever was possible, we have achieved by mixing these materials at the normal temperature or the room temperature also, or maybe below 50 degrees centigrade. Nowadays, which I just showing the slide, this is warm mix asphalt. In warm mix asphalt also, it is in between cold mix and hot mix technology. We add the materials like sesobit, like redicet, etc., in which the highest temperature is lowered by about 30 degrees centigrade. So these warm mix additives are in between cold mix technology and hot mix technology. But I tell you, though it is good, we are able to check the environment pollution by using the cold mix technology or the warm mix technology. But the quality which we achieve in hot mix is not achieved by any other method. But since we have to see both the things, we have to see the environment pollution also. That is why we go for cold mix technology also. Any other question?